see the last part, the fourth part of the Cauchy, Schwarz, inequality. And this is the fourth way, the last way in here. And the first way we're going to do is, let's use this part. We're just not moving this part here, but we're just using this part minus this part. Actually, create this one, but it's not really, just move it right here, okay? And so now let's see here. So if we use this part minus this part, so what we get? So what we have first, and of course, we're gonna find out sigma I equals 1 to n, and then ui squared times sigma I equals 1 to n, and then vi squared, and this one minus sigma I equals 1 to n, and ui vi bracket squared. Now we're gonna find out this one, and actually I have calculated about the after I have calculated, because right here actually this is n dimension right here, because ui and vi and I is 1, 2, 3, 4 to n, and it belongs to Rn. That means it's really not in n dimension. Actually, we're not just n dimension. And actually, I have calculated this part about the problem right here. This part about R2 and R4 on my manuscript. And if you are interested in it, so I'll show it on screen. But today I just show about the R3, and then that led us to summarize the final equation of Rn. Okay, now let's do it. So I just talked about R3, right? So let's try it out. Let's just plus it out. So u1 squared and plus u2 squared and plus u3 squared, and then bracket, and then times v1 squared and plus v2 squared and plus v3 squared, and minus, let's see here, minus bracket minus, and here is it's u1 v1 plus u2 v2, and then plus u3 v3 bracket squared. So what we do next is let's times it out and actually find our answer. And actually, we're just easy, okay? Very easy to prove it. And well, I just talk about this time this time this, and this time this, and then this time this time this, and this time this, and then this time this time this time this, and that's very easy problem. I don't talk about it. So u1 squared and times v1 squared, and then plus u2 squared, u1 squared, and then times v2 squared, and then plus u1 squared times v3 squared, and then plus let's see here, u2 squared, and then v times v1 squared, now v1 squared, and plus u2 squared, and then v2 squared, and then plus u2 squared, and then v3 squared, and then plus u3 squared, and then times v3 squared, times v1 squared, and then plus u3 squared times v2 squared, and then plus u3 squared plus times v3 squared, and then minus Okay, minus. Right here, what's this? Let me see that. And then minus u1 squared, v1 squared. And then, let's see here, and that's minus u1, v1, u2, v2. And then minus let's see here, what's it? u1, v1, u3, v3. And then minus u2, v2, and times u1, v1. Okay, and then minus, let's see here, let's see. Okay, and it's u2 squared times v2 squared, and then minus u2 v2 u3 v3, and then minus, let's see here, and then minus u3 v3, and then and then u1 v1, and then minus let's see here, what's that? It's a u3 v3, and then times u2 v2, and then the minus what's it? And it's the u3 squared, and then times v3 squared. Okay, and actually, see, here's a lot of things, and so what we do is first you can probably can find out here. We can cancel out these things right here. Okay, I can cancel out this one with this one without a line right here. Where is it? Okay, hey, where you are? Let's see. Where you are? Okay, so let's count all these guys first. So what we do next? Oh, you just read it. I don't even know use different colors. Yeah. Okay. Just colors. Yeah. Okay. So first, let's see here. Yeah. So first, let's see here. So we see it's 1 and 2. You don't know why? Just try these guys together. I'll tell you later here. 1, 2, right. So let's find here 2, 1. Yeah, so 1, 2. Let's find here 2, 1. Here with 2, 1. Okay. So we have now equal to. Let's see here. Actually, what we got. See here. Actually, you see here. Actually, we can change it to 2 times, right? You see here because these two guys actually can say this is u1 v2 times u1 v2, and here's u2 v1 times u2 v1, and right here is 2 times u1 times v2, and then times v1. Sorry, u2 times v1. So it actually. We can change it to, so like, I can say it's, okay, and we can actually change it to u1, v1, and then minus u2, v1, bracket squared. And actually this part, if you just opposite these two guys, right, actually that's fine if you times them out. Into the next pair. Let's see the next pair. Next pair is 1, 3. So let's find 1, 3, 1. Right? You understand that now. You know why. Right. Okay. Where's 3, 1. So we want 2. Here. Yeah, okay, wait. So, okay, next step is, okay. And I don't talk about why because you understand. Okay, very perfect. So, this is U1, what's that? V3, and then minus U3 V1 bracket squared. And the last pair is 2, 3, 3, 2. Yep, 3, 2. And 3, 2 here. Oh, what's 2, 3? 2, 3. And 3, 2. Okay, so what we have now? Plus. Here, not plus this color. Plus. And bracket 2, 3. Sorry, not 2, 3. U2 V3 minus U3 V2 bracket squared. And now we have it. So actually you can explain using sigma. So first let's see if we just using it to explain like sigma I and j is equal to 1, 2, 1, 2, and 3, and then u I v j, and then minus u j v 1 bracket squared. Bracket squared. So, and actually you can find out this part. It has 2 parts actually they're the same. Because you can find out here, if we choose 2 values they're the same. You see, 1, 1, so these 2 parts is in the whole part is 0, and 2, 2, this whole part is 0. So just like they're just going to be canceled out. And if you say, and it's a 1, 2, or you can say 1, 3, or you can 2, 3, these 3 guys, you see, they have, and because IJ can choose 1, 2, and these 2 can choose, IJ still can choose 2, 1. And actually they're the same right here, but you see, right here, so we need to cancel out one of them, and it's the same with 1, 3. It still can be 3, 1, and then we're going to cancel out another one, and then you see 2, 3, and we have opposite 1, 3, 2. So we need to cancel out 1, 2. So we're just using divide 2. We can say times 1 over 2, so it's 1 over 2 so far. And now, so just like what I said before, right? So now we can summarize the final equation of our n. So that's easy, right? All we have now 1 over 2 and sigma. No. Yeah, it's right here. 1 over 2 sigma I j equals 1, 2, 4.2 n. Okay, and what's up beside? Here is saying ui vj minus uj vi bracket squared. So what we do next step, and now you know what is this about. So maybe it's greater or equal to what something or like that, just like that. And let's think here. Each term, because right here is square, so each term is greater or equal to 0, right? So the whole thing is greater or equal to 0, including sigma, right? So of course including 1 over 2, right? So this is greater or equal to 0. Okay, so actually, so that means we could say this part is greater or equal to 0. So what means we can just move this part to here, and we just got the Cauchy, Schwarz, and Cauchy. But so now the only problem again is, so how do you prove if when you let the both sides both sides of the inequality are equal? We just think about it in function right here, no here, okay, just here, okay. Let me think. Every term, because every term is greater or equal to 0, no negative. So every term is greater or equal to 0. So each term will be equal to 0 if the whole thing will be equal to 0. So each term will be equal to 0. So how do you do now? Let's see here. So we can just say, because it's minus, so we can just talk about like u1 times vj, and that's equal to uj times ui times vj, and then equals uj times vi, times vi, and then we can just both sides divide vj vi, and we have ui over vi, and then that's equal to uj over vj. So of course right here, you may have some problem. You see here? You see, so what about the denominator is equal to 0? So if this is 0, so it's undefined. So what about it? Actually, it's fine, because from the last 3 videos, we know actually this problem is a problem of vectors. So actually, you can think. You see, ui, vi, they are just a pair of, we just talk about, and you know what's a pair of. A pair of coordinates in the same axis like that. So, in the n dimension like that. So actually, you know, like here, let's think, if a pair of coordinates is 0, so actually you can think, we write on the picture, we can think the dimension is decreased 1. So it's the dimension is decreased 1. So let's you can say like if it's 3 dimensions, so decrease to just because you see decrease 1, and if the dimension is decreased 1, we can just think it is It's a projector, right? So we can say it's 3 dimension and it will project the 2 dimension. Like if we say a pair of coordinates on the x-axis in the 3 dimensions, so x-axis will project, right? Project out, and so the 2 dimension is YZ plan right here. You can say like that. So this, you see, if we say it's a 3 dimension, it will project to 2 dimension, right? Like that. So we can say, that means actually, and of course, you see, if I just let the y ratio, like I only have ui, vi, it's just only left because others is all zeros, so we can say it only left this part. Actually, this inequality will change it to equation. So that actually means, so at least if we in n dimensions, so at least you need to left 2 pair of coordinates is not equal to 0. So that is still fine, but if it's not, so it can't be, right? So it can't be in this problem right here. Or you say, or if it 1, so the inequality, I just say like that, the inequality will change to equation, right? So that means what? So we have this problem, right? Okay. Now we actually use we just easy calculating, and we can just still prove the Cauchy Schwarz inequality.